We, the Indian Society of Heating, Refrigerating and Air Conditioning Engineers, ISHRE, stand tall in the Indian industry with over 10,000 professionals as members and almost an equal number of student members. Founded in 1981 and headquartered in Delhi, we operate from chapters and sub-chapters spread all over India, bringing our entire industry together. Individuals become members of our society according to their professional and academic standings. Our roadmap of the future looks very bright, with thousands of new members joining this technical society every year and bringing in a fresh outlook to our industry intelligence. ISHRE disseminates knowledge through its technical committees, which consists of some of the best minds of our industry. It publishes technical books, newsletters, and a prestigious journal, distributing the wealth of knowledge to all its members. Working with government departments, ISHRE helps formalize industry codes and standards. ISHRE promotes research by offering financial support to student members to carry out groundbreaking work in technology, systems and processes. Our educational wing, ISHRE Institute of Excellence, organizes training programs and workshops to help members enhance their skill sets. Our specially designed certification programs under ICP, that is, ISHRE Certified Professional, empower professionals to always be in step with the prevailing technology. Specially designed courses for technicians are offered to meet the ever-increasing demand for a skilled workforce. ISHRE organizes exhibitions, conferences, panel discussions, and product presentations throughout the country. We organize the industry's largest international exposition in South Asia, Acrex India, to showcase the cutting-edge technology, innovation, and provide a platform for closer interactions amongst the decision makers in the industry. The Acrex exhibition is now growing from HVAC&R show into BFA, Build Fair Alliance. This brings together several allied shows connected with the building services industry all at one location. Our chapters organize several other popular events like AgriConf in Delhi, Raycon in Kolkata, Symposia in Mumbai, TechFest in Goa, and many more. We are committed to provide training and career guidance to our student members through seminars, lectures, quiz contests and site visits. A-Quest, a prestigious quiz competition organized by ISHRE to catalyze the transformation of the budding engineering professionals. ISHRE provides a platform to potential employers to select student members for careers in HVAC and our industry at the ISHRE Job Junction. Young minds are made aware of the need for saving power, clean air, and sustainability. The K-12 initiative of ISHRE focuses attention on school students' development to inculcate a scientific fervor and help develop them into responsible citizens. Speedy information is imperative to keep moving forward in this hyper-connected digital age. Searcher, a specifically designed search engine, is now available, which allows access to a well-catalogued database on HVACR and building services industry with just a few clicks. ISHRE cooperates with various national and international bodies, industry, governments, academia, think tanks to promote the concept of sustainability, environmental protection, and energy efficiency and conservation. To enter and explore the universe of the Indian HVACR industry, log on to ishre.in that unfolds a panorama of information Let us engineer a sustainable future together through ISRE.
Good evening, and thank you everybody for joining this session. As you know that today we'll talk about air filtration technologies, and of course we have expert speaker for that, Mr. Vishal Jain sir. We would like to welcome on behalf of Delhi chapter of ISRE. We welcome all the panelists. Of course, Mr. Arun Duhan is also there with us. He is core committee member for Delhi chapter of ISRE. So, of course, we are also thankful for all the annual partners to support this program. Platinum partner Armacell, Gold partner KSB and Aeroflex, Silver partner Movex, Briar DRI, Syscam and Advanced Wall, Annual partner Andrews Hydro, Paramount Poultry, KFlex, and membership partner Standard Refrigeration. So, without any further delay, I request Arun Dwan sir to proceed with the introduction of Vishal Jain sir. Thank you. Over to you, sir.
Thank you, Tapas. Thank you very much. First of all, I would like to thank Mr. Vishal Jain to find some precious time and to educate, the newcomers and the society about the air filtration. Let me share his introduction. Mr. Vishal Jain, he has been, a quarter of century he has passed in, he has in IT and telecommunication. He has been at a senior level in the industries. He on the visionary product development with the deep education and research and analytics. One thing which nobody knows, let me introduce all of you. Why, after spending 25 years in IT and telecommunication, why Mr. Vishal Jain jumped into the air filtration and, the air pollution and all these, there is a story behind. In early days, Mr. Vishal Jain's father was suffering, some respiratory problems, some asthmatic. So he turned into the situation how he can help his father and the society. So he took aside the 25 years of his experience in IT industry and jumped into how he can make the air filtration and the environment better, which can help his father and the society, of course. So this is how he came into the air filtration and the pollution industry. So this is very specific, in which nobody knows, although he has a IT and telecommunication experience, but now he is into like air filtration and the air pollution control. So thank you, Mr. Vishal Jain, for your contribution for the society. Thank you. Please, over to Mr. Vishal Jain now.
Thank you, Arun. Thank you, ISRE committee members. Thank you, all attendees. Thank you, Mr. Arun, for having the great and sweet introduction of mine to the whole community here. Yes, sometime, we need to take hard decisions, and that's what I guess everyone has to see how they can contribute, their time and their effort benefiting to the world with their contribution and their knowledge. We must do something for the society, and that's what the thing I took in last 6 years, and taking it forward, because air pollution is a really big problem for the developing countries like India, and we must do something related to this. And that was the whole intent. I requested district committee to have a knowledge sharing session to the people, because air filtration and air pollution, it's still a relevantly new thing, and we don't have much of expertise yet. But there were a lot of research already happened, so I've combined my all skills and knowledge to a presentation, which I'm going to present it here now. So I hope everyone is doing good. who have just joined into this session and at peace at their home or offices and can utilize most of the knowledge which I'm sharing here to their to their program projects or in their businesses maybe. So once again, thank you everyone and good evening. So I'll just share my screen, Mr. Arun. I hope
Yeah,
I
please.
have the access. Yeah. Hope you can see my screen.
Yes, sir.
All right. Okay, so just a short summary on the session. The session is all about the air filtration technologies and how we should do the evaluation and method of selection before taking any project in hand. So a small presentation actually will help getting more insight about the various filtration techniques, where various methods, their working principles, their advantages and disadvantages, and how we can utilize the right resources for the right solution. So hope you will enjoy the session. We'll start with the first thing is air pollution. I'm assuming that most of the people joined here knows about the air pollution already. So I'm not getting into much of details. If we see the simple definition, is the contamination of the air due to the presence of the substance in the atmosphere that are harmful for the humans, living beings, and can cause damage to the climate or maybe other materials. Now these days, also damaging the machines. The air pollutants are, as we already know, there's the gaseous pollutions, particulate pollutions, biological contaminations, and even radiations are also being considered to the air pollution. So as the air pollution, the air filtration goes hand in hand now. So various air filtration techniques have been adopted to optimize air quality, and air filtration techniques can remove air pollutants and effectively improve the deterioration of the air quality that we all know. This presentation actually a comprehensive review on the synergistic effect of a different air purification technologies. Saying the synergistic effect means the combining the various air purification technologies together and using the air filtration theories and materials of standards. Evaluation of different air filtration technologies, which will considering factors like their energy and economics behavior, working principle, their impact, their performance and efficiencies. So that's all in a nutshell. We will have a quick look in the following slides. So before we start getting into the filtration technologies, we must know, from where it has all started, what are the theories and who has actually started all these theories. So early classical filtration theory in 19th century to the modern filtration theory and microporous filtration theory, it all started in 19th century. The fine particulate movement or particle movement was first observed by scientist Mr. Brown in the early 19th century. When the fine particulate suspending was observed into the liquid, which was defined as a Brownian motion. I guess most of the people we already know. In 1922, Freundlich presented the understanding of the law on aerosol filtration and indicated that aerosols particle maximum permeability exists within the radius of 0.1 micron to 0.2 micron. So these were the great findings by the researchers. I have combined a list of researchers which has actually helped us in the past, finding the size and the characteristics and properties of various particles into the air, their laws of various laws and filtration theories, the the practicals done to have separations of the particles from the air. So this is the chronological order of the most of the key achievements achieved by the great researchers in the past. This slide will be shared after the presentation to the all attendees, so you can probably have it handy and you can read out with the for the researchers and more yourself. So let's understand the particulate matter. Most of the media, communication, news, articles, theories talks about the particulate matter. And this is the key component when we talk about the air filtration. We must know what is particulate matter. So matter, if they all know that there are three matters: solid, liquid, gas. There is a fourth matter also considered as plasma, but plasma doesn't pollute so far. So the three key elements, solid, liquid, gas, are the usual suspended particulate matter that we know as aerosol in the atmosphere. And this all solid, liquid, or gas matters could have different shapes, could have different size, their characteristics, their different properties, their reaction to the different resistance levels against the force, electricity, or any other external action. The filtration systems designed in past or now being designed for the future are evaluated basis on the various factors of the behavior of the particulate matter. So we must understand and measure the properties and the characteristics of all three matters before putting up the filtration system, and that's what we will see and learn in the following slides. If we take a solid matter in hand, and usually the solid matter, when we it's called dust, and everyone knows it's a dust, and dust is usually having the silica, sand, salts, minerals, mica, glass, wood. There are several things as fine particles or coarse particles are counted as dust as combined. And these are also characterized based on their properties to the simple dust and the difficult dust. The difficult dust are the ones those are not normal in nature. So it could have very small particle size. It could have very low density, or could be have very low mass or high mass. It could be fibrous or non-fibrous particle. It could be sticky particle or abrasive particle, could be reactive in terms of explosive particles, hot or cold particles. So there are different characteristics and the properties which actually define different behavior for the dust particle. These are the key points which must be considered before selecting the filtration system, because either the filtration system will not be so efficient to deal with the particle into the air, or can create a byproduct or can harm otherwise. So a detailed analysis of solid matters must be done before finding the right filtration solution. When we talk about the gaseous matter, again, in natural air, some secondary particles derived from the oxidation of primary gases like sulfur and nitrogen oxide into the sulfuric acids and nitric acid, and it could be in the liquid and the gaseous form both. In the presence of ammonia, the secondary aerosol often take the form of ammonium salts, ammonium sulfate, and ammonium nitrate, and it can be again dry or the liquid formation. But in absence of ammonia, the secondary compounds could be acetic, could be nitric acidic, sulfuric acids, which is again the liquid droplets as aerosol. So this is very important to understand that the gaseous matters can also produce the liquid matters based on their reactions and oxidation properties. Organic matters like the VOC, volatile organic compounds, are also the aerosol available to the gaseous matter. So as I just explained, the liquid matter into the air or as aerosol droplets formed due to the water as avidity, or could be a gaseous byproduct formed during the reactions into the air. So that's now we understood about the the solid, liquid, and gaseous matters as aerosol as pollutants into the air. Uh, so now let's have a quick review that what are the working principles which are being used or being identified by the great researchers in the past basis on the various filtration techniques. So inertia, impaction, diffusion, interception, gravitation, absorption, agglomeration, electrostatic ionization and polarization, catalysis, radiation, compression. These are the the back-end working principles behind the various air filtration techniques those been adopted or being adopted in the past. I'm sure most of the engineers knows about what is inertia, what is impaction. So I'm not getting into the detail of that. But if somebody wants to know more about it, they can always drop an email or can reach me out. I can probably help them explain. Or we can have another session if required, based on your input about all these working principles. So based on the working principles, this is the chart or table is drafted, which high level says what is their effectiveness levels on what kind of pollutants. So if we see the purification techniques are listed here, and we have actually bifurcated the pollutants into the suspended particles as solids, gases, and microbiological order with their size difference. So the mechanical filtration system are usually the fabric-based filtration system we see works very well and very effective for suspended particles like dust, pollen, lambats, etc. But they are not good to have their effectiveness on the gaseous contaminants. Microbiological contaminants could be effective, non-effective basis on their size and the diameters. So as the absorption-based system, which like the grid blocks or maybe the granular media or activated carbon, they're partially effective for the suspended particles based on their pore size, but they are very effective for the gaseous contamination arrestance. They are equally effective and non-effective based on the size of the pore size, which can probably arrest the bacteria and the virus. Water washing techniques is also as a purification system is effective for suspended particles, mainly solid, partially for the gases, and they are not effective in terms of removing the bacterial and the viruses. They will get dissolved into the water and nothing will happen to them. Electrostatic precipitation, where the high electricity intensity being used for the air purification, very effective for the solids pollutants, but not observed as effective for formaldehydes or gases. But since it has a high electrostatic charge, sometimes burns the cells or dehydrates the cells. So works for partially effective and non-effective for the bacteria and the viruses based on their size and nature. Similarly, there is a photocatalyst, plasma cleaning, ultraviolet has different effect on the different kind of particulates into the air. So one thing that we can understand from this chart, that characteristics of the different purification technology can be concluded that the purification technique cannot succeed in an environment characterized by the multiplicity of the air pollutants, because there are multiple air pollutants. So in order to purify the air to the fullest, it is necessary to combine various purification methods corresponding to the types of pollutants present in the air. So there is not one kind of techniques can work to the fullest to clean the air. So we have to probably combine to get the best output from the filtration system. If you see the pros and cons chart of again basis on the technologies, there are relevantly good and also not good on some aspects. If we take about the fiber filtration system, as we know, very good for the particles and the microorganisms, as we've seen into the last slide. But their advantages are they are low cost, very easy to install and implement. But their efficiencies actually depends on the pressure drop, the resistance of air. They're usually high resistive for the air flows. Electrostatic dust removals, very good for the particles and microorganisms, but again, there's a high investment needed because these are the costly machines, which also requires a regular electrostatic fields. And if the electricity field is not working, then there's a puncture in your filtration system. So that's a disadvantage. Also, the maintenance and the cleaning is frequently required because the efficiency curves declines with the dust loading on the electrostatic plates. We will talk about detail in how the electrostatics things work, how the fabric fibers works in the following slides. Same as ultraviolet sterilization system works very well for the microorganism, but if you talk about the the flow rate of the air, the velocity of the air, the efficiency decreases with that. So it has to be rightly calculated, and if it is overly done, then it can create the byproducts as well. Activated carbon as adsorption works very well for the gases contamination, but again, they get saturated, so can't be regenerated. So we have to throw the media, and we have to use the media. We have to buy the media again. They are also very resistive for the airflow. So these are the disadvantages for that particular solution. Negative ions are very good for particles and microorganisms, but they produce as a byproduct ozone, secondary pollution, sometimes decomposition of the dust. Also been observed, disposition of the dust also observed near the discharge streams. So let's say you have a vent which is having the air, and also the ions are coming. So you can probably see that walls turning black because of the accumulation of the dust, deposited over the walls. Photocatalytic treatments or the techniques, again, very good for certain kind of pollutants, but they also carry the negative and disadvantages because they are slow processed purification system. They also produce secondary pollution in response to
Jen sir, hello. Sorry
Yeah.
to interrupt you, sir. Can it would be a little bit loud? Your voice is coming little slow.
Okay. Is it better now?
Yeah, it's better now, sir. Please.
Okay. As I explaining, the photocatalyst treatments also brings pros and cons, and the cons are the reactions are slow, doesn't work for particulate matter, and they also create the secondary pollution if the reactions is not completed. So these are the high level advantages and disadvantages. The disadvantages could be listed in various factors and the manners based on the economical factor, installation, size and dimensions, their energy efficiencies. There could be n number of factors for the advantages and disadvantages. This is a slide I have tried to combine together to explain how the synergetics effects works. We were talking about various pollutants, we were talking about various techniques, their pros and cons, but as we said that one particular filtration technique cannot work for all kind of pollutants. So how the synergetic effect works? So I have just taken some example of some brands. Those are using multiple technologies for the air purification. So take an example of Blue Air here, which using the fabric-based filtration system. They also have adsorption, electrostatic precipitations. So all combined together, they are trying to cover the maximum band of air pollutants from the size segment. Sharp has also created the plasma cluster ion. Daikin, has most of the technologies combined together. So this is a representation wherein integrating various technologies together to get the maximum or the fullest outcome of the maximum purification efficiencies. So now let's study about the filters. I have actually, distributed into the three segments. One is the mechanical, chemical, and biological, basis on the working principles. So and have also tried to list which works best for what kind of matter. So if it see the first section is about mechanical, those works very well. Let's say settling chambers works very well for the solid matter, cyclones, electrostatic precipitators, spray towers, venturi scrubbers, bag house, fabric filters, which works very well for the solids, deep bed scrubbers. So these are the popularly known techniques or filtration systems, those being widely used in various sectors like industrial, commercial, domestic, since long, and very proven from their efficiency perspective. But yes, as I said, something works for some kind of pollutants, and other thing works for some other kind of. So we will get into all the details one by one. So let's see how the settling chamber works. So the settling chambers is the simplest architect or designed system, wherein there is a chamber which is called dissegmented chamber, and there's air stream which goes in and out. But if you see from the design, the air stream which with the airflow which comes as on the inlet gets lower into the speed into the this segment chamber, and because of that, due to the gravitational force as a working principle, the particulate matter, those are bigger in size, gets dropped into the hoppers. And once the hoppers are filled, we take out the dust particles from these hoppers, and the air which goes in and out gets clean here. So it's a simplest way of cleaning the air, those having the bigger size of particles. It doesn't work for the fine filters or fine particles. Widely being used into the industrial emission controls, like for dust, fibers, metal chips, etc. These are reusable system. Yes, that's a great advantage, because once deployed the system, you can use it for n number of years with the regular cleaning and maintenance. The biggest disadvantage is these are usually very big in size and nature, and that's the reason widely used into the industrial emission controls. The second type of most popular system, and specifically into the industrial sector, is the cyclones. And again, it's a very simple designed system, wherein there's a one inlet for the airstream and there's an outlet of the airstream, but it's on a very high velocity that once it reaches to this vessel, which is cylindrical and conical in shape, there's a cyclone produced. And with the working principle of inertia, gravitational forces, and agglomeration all together, the particles actually drops again to the hopper, and the air stream which is revolved into this vessel gets clean. It is again a very good and highly efficient for the bigger size of particles. Even it works for the smaller particles because of the agglomeration. Widely used for industrial applications, again for dust, fibers, metal fibers, woods, and etc. This is again a reusable system, because once deployed, just a cleaning is required and works well for many years. The disadvantages about the system is it is difficult to remove wet or sticky particles. It has to be dry. So usually before putting the cyclones, there the air dryers are also installed to get the maximum efficiency out of it. If we just take a small example, that if we add the let's say ionization to the air field, the agglomeration can be increased, and we can get the better efficiencies even on the fine particulate matters. And sometime there's a after filters also installed to capture the fine filters, those doesn't get dropped here. So that's a high level understanding on the cyclones. Again, the third one is the electrostatic precipitators, widely used again since many years for industrial application. It was actually designed for the industrial application for smoke and the oil mist collections. The good part of the electrostatic precipitators are they are very efficient even for the smaller size particles till 1 micron, and the working principle is the ionization between the plates. There is a charging plates and the collection plates. When the air passes through the charging and the collection plates, the particle matters, those are into the air, gets charged and gets collected over the collection plates. This requires high potential corona to be generated. The corona discharge is the voltage when the air becomes conductor. Usually also called the barrier voltage. Above 8,000 volts being operated here, and the disadvantages of the system is that when the humidity levels are high, the efficiency goes down, and this system also generates gaseous byproduct. In the airstream, as we all understood that there's a solid, liquid, and gaseous matter. So in the natural air or the flue air, there are multiple natural gases and multiple VOCs, which also gets passed through this corona, discharge or the plasma field, and their electrons gets excited, which starts reaction to the other gases or with the water droplets into the air, and creates byproducts which are usually not even available into the natural air. So that's a big disadvantage of this system, but it works very well for smoke and oil mist or particulate matter arrestants otherwise. The efficiency curves is downwards, so it requires a regular cleaning and maintenance. That means, with the dust loading, the efficiency drops, and that could be another big disadvantage because it takes a lot of cost and effort to clean the bigger and the bulky systems. Wet scrubbers are also very popular as a purification technique in the industrial and commercial sector. Once again, the working principle behind the wet scrubbers are impaction, interception, adsorption with the water droplets. So this is again a simple design architect model wherein the air stream goes in with the liquid or the water droplets inside to a chamber, becomes a cyclone inside, and the water actually dripping from the waste eliminator over the air actually separates all the particles from the air stream, and the clean air comes out. The biggest advantage of this system is it works well for solid, liquid, and gaseous matters. So it works for all three. Only thing is, it reduces the water pollution related problems because this water becomes acidic after multiple recycle of the cleaning, and it becomes a health hazard as a byproduct. So that's the reason it is limited use now, and most of the dry scrubbers being used. Let's come to the most popular fabric based filters, the mechanical filters. I'm sure everyone knows about it. So mechanical or the fabric based filters are widely used in most of all the application, could be domestic, industrial, commercial, for indoor air quality or emission control. There we see the most of the working principles being applied: diffusion, impaction, interception, adsorption, gravitation, inertia, electrostatic. Every working principle works here, and the biggest disadvantage is these are use and throw type. The cleaning is not that effective, and if we wash it or vacuum it, the most of the pore size gets disturbed, and that impacts the efficiency levels. The biggest disadvantage of the system is, usually have a high pressure drop, and once the dust is collected over the fibers or the filters, it forms the dust cakes, and their properties or the efficiency of the cleaning also varies depending on the properties of the fiber or fabric being used. Uh, in the slide, I have tried to combine, a data which is very helpful to understand, what kind of fiber or fabric is more efficient to use the filtration system. So we could have cotton, polypropylene, acrylate, nylon, wool. There are different kind of fabric and fibers available with different, their yarn and uh, the architect type of their spinning. They operates on the different temperature levels. Their resistance to the acid, chloride, alkali, or their flexibility levels are way different to each other. So is their tensile strength. So as I said, the fabric filters are being widely used in most of the applications. But before selecting the right fabric or fiber for the filtration, we must know that for what application we are using. Is it high velocity? Is it high temperature? Whether the flexibility is required? What are the the levels of acids into the air or chlorides into the air? Because it is going to react with the fiber and fabric, and that will impact the efficiency of the filtration system. So it is very important to understand. Next comes to the deep bed scrubber. Again, a very good filtration technique. It works very well for the gaseous matter, not for greatly work for particulate matter or liquid. The working principle is absorption, and catalyst. So it basically depends on the media that being used as in deep bed. The biggest disadvantage is about the reusability. Most of the media which actually absorb the gases contamination is not being reused, and if we have to regenerate the media, there's an additional cost to it for the regeneration, and sometimes it is not easy. So it all depends, what kind of gaseous arrestment being done on the media. The structure is, again, it's very simple. There's air in and air out, wherein there's a deep bed of granular media, which is could be a blend of activated carbon, zeolite with different level of impregnation is used. So the selection of the deep bed or the selection of the impregnation depends on what kind of gases we need to arrest or remove. But deep beds provides about above 99% purification if they're rightly calculated. The another technologies which is photocatalytic technology is also a very good technology, and it works very well for gaseous matter, specifically removal or eliminating the VOCs or microbiological contamination. The working principle is the catalyst, which is nothing but the photocatalyst is the acceleration of the photoreaction in the presence of the catalyst. So basically, a light as an energy source is used with the catalyst to have an chemical reaction into the air. It actually produces the hydroxyl radicals with the reaction to the water droplets into the air, and this hydroxyl oxidation radicals, hydroxy radicals react with the sulfur dioxide or ammonia or nitrogen dioxide, which is present into the air, and usually decompose to the inert substances like H2, HNO3 or H2SO4. The biggest disadvantage of the technology is, the reaction is very slow, and cannot be deployed for high velocity systems. If you have to deploy for the high velocity systems, then the intensity of the light and the catalyst has to be increased. The example for this is the UV with the TiO2, wherein the UV light is used to excite the titanium dioxide, which actually generates the hydroxyl radical into the air, and from there the reaction happens, as we have tried to explain within this picture. So now the application part, there are various paints also coming for domestic purposes. If you put into the wall, they start cleaning the air, usually removes odors and the VOCs in homes or indoors, and also being used for microbiological decontamination. During the last corona pandemic, such kind of technologies was widely used in the world. There comes thermal oxidizer. This is again a very popular, purification system, and this is again is widely used in industrial and commercial applications for the corrosive and toxic gases control. Usually, the VOCs or hazardous air pollutants were passed through the thermal oxidizers, wherein the high temperature or the burners are used to oxidize the gases which is coming into the air. Usually the constructions are simple, but the cost of operations are very high because it takes fuel and energy to form the combustion, and the regeneration, there's the heat losses as well. And nowadays, the regenerative thermal oxidizers are also coming, which you can see into the picture. There's a heat exchanger media also used to get the maximum out of output from the energy that was used to burn the gases. As a matter of fact, these regenerator or thermal oxidizers produce CO2 and H2 as an ideal end product into the complete process of oxidization. Electron beam is also used from application to application, wherein electron beams as ionization, bipolar ions being used in place of the oxidization chamber, like the thermal one. So usually the construction remains same, but in this the gaseous corrosive gases or VOCs were removed by using the ions into the chamber, and these ions again reacts with free radical ions reacts with the molecules of the gases, and different byproducts being generated as an inert substances, which actually gets removed from the contaminated air. So if you take an example, the bipolar ionizer and the plasma generators are the examples which now being used into even the domestic applications. But it requires high energy levels to create electron beam, and sometimes uncompleted conversion creates byproduct. So usually this system creates a byproduct, and that's the reason it is not widely used, but for some specific applications only. So that comes to and towards the end to summarize, what we have understood from the presentation, that the air pollutants, as a matter of fact, could be solid, liquid, or gas, and all pollutants have a different properties and the characteristics. There is no one filtration technology or method that can remove all pollutants, and that's the reason it has to be critically evaluated before the selection of the filtration technique, method, or any product. There are related pros and cons for each kind of filtration system, and that cannot be completely eliminated, because one thing works for good for one pollutant, but it may not for other, and also may create a byproducts. So it has to be critically evaluated, and we must also see the reusability, sustainability, and energy efficiencies before selecting the right filtration system. So hope the data and the points for the selection methods as we have just run through can help finding the right filtration systems for any of the projects or program. So thank you for your attention. Hope the session was informative enough for yourself. If there is any questions, you can drop me over the email or you may ask here.
Thank you very much, sir. We'll wait for a couple of minutes to questions to come in Q&A section. I request everybody to send your question in Q&A session. We'll take it one by one.
Any questions, attendees or the participants?
Sir, one question.
I think there is a
go on, sir.
question in QA session asked by Arpan Kedia.
Yeah, hi. Yeah, I can see that.
Yeah.
So the question is how we are going to decompose the filter and pollutants, which may be dangerous for environment. I guess this is a very good and relevant question, and most important because wherever we are putting the filtration system, usually we throw it back to the environment, and which is not good. Just take an example of the mechanical filters which actually collects dust. So before throwing back to the environment, it has to go through a process wherein the arrested dust should be taken out from the filters, and it has the dust again. It could be a coarse dust or the fine dust. It has to be used for in some kind of commercial or industrial application rather throwing back into the environment. And even if it has to go to the back to the environment, it has to be used with certain kind of treatment so that the complete elimination of biological contamination or other things can be done. This is the very lacking part specifically if we talk about in India. There is no such one stop shop which provides all kind of depolluterization or decomposing the filters, and it has to be worked out.
Well, I have a question, very simple question, Chansa, for you. If you are hearing me.
Yes, sir, I can hear you.
What do you recommend in a present scenario in a current era? The everywhere, the urbanization is going on a large scale. We are winding up with the forest and the greenery. So
Right.
what do you suggest for in general I'm talking about, what do you suggest for having a fresh breathe in metropolitan? One should what are the measuring parameter one should apply to have because all these filtration processes are in the either in the industry or some big plants, But when we talk about in general for a normal, the human beings, what should be the measuring parameter? What should be the process one should apply for having the fresh air in the house or home, like, or in the small offices, like.
Yeah. So, sir, as you have rightly said, this urbanization has caused lot of air pollutants into the air, and mainly coming from the industrial emissions, constructions, various industrial processes.
Yeah.
So the one thing is if we can suppress the pollutant at the source level, that's what the key stuff. We can have any kind of filtration system applied for our homes or our offices, but it may not solve the entire purpose. It can have a limited efficiencies.
Hmm.
Once we are stepping out from our home and offices, we are again exposed to the pollution. So we have to control the emissions by putting the right solutions for that particular process. And that has to now the government is also doing, taking many steps towards it. There are earlier there were no monitoring systems in place. Now there are various monitoring systems in place, and we are quietly aware about the levels of the air pollutants. For the domestic, air purification solution for homes and uh, offices, I would say first thing is the right ventilation system is needed, because if we have right ventilation in our homes, so the pollutants that we are creating inside the house while cooking or cleaning or something can be diluted. Second thing is, if there are closed room or air conditioned rooms, usually the CO2 levels gets increases. So with the right ventilation system, it gets diluted. Other pollutants like the particulate matter which is coming from outside, if we make our house positive pressure with the right ventilation system again, pollution coming from the doors and windows gets limited and can be reduced. And if we have some kind of basic filtration in our air conditioning system or a small air purifier, then they also helps increasing the efficiency. But 80% job can be done if we have a right ventilation system into the homes.
Right. I think that is a perfect. Right. Right.
Thank you, sir.
Good. The Arpan Kedia is, again extending his question. Can we take this part?
Sure.
Yeah.
Do we have a BIS standard for
No,
the
no, no, no.
indoor?
Arpan Kedia, but there must be.
Okay. But there must be a mechanism from the manufacturers of the filters or some guidelines from the government. So absolutely, and that's what I'm sure the community and associations like ISHRE pushing Central Pollution Control Boards and relevant organization now, that we need to have methods and means for disposing the air filters once they are saturated.
Certainly,
And
certainly,
yeah, and
certainly.
I will also maybe I will request ISHRE committee if we can share what kind of initiatives being done so far to Mr. Kedia, that will help him a lot.
Can I add few lines on your behalf to
Sure, sir, go ahead.
satisfy Arpan Kedia?
Yeah.
Another query. See, Arpan, there is standard guidelines from by the government when we dispose any pollutant or the filter which is contaminated back to the atmosphere. If I talk about like any filter from virology lab, because I deal in virology labs and the hospital or the major OTs. When it comes to the virology lab, there's a contamination, virus contamination, huge, very dangerous. So in that case, the filter is cleaned mechanically, and then air is passed through that filter again, and it is checked by the third party government officials. Unless that government official third party approves that this filter is now okay and all the contamination has removed, it cannot be disposed of. And like this, am I right, Vishalji? Am I right?
Yes,
Right,
sir. You are absolutely right. Yeah.
okay. So
So
in this
mainly,
way, yeah, in this way, everywhere in the government sector and in the private sector also, the guidelines are there, and of course, the ISHRA is doing the hard work again to make this, the very common for the general public and the normal offices these days, because the pollution is a very big problem these days, and the we have to take the air filtration in normal offices. Early days it was not so prominent, but these days, I mean, ऑफिसेज में भी हमको जो है एयर फिल्ट्रेशन का बड़ा ध्यान रखना पड़ता है. So the government on his side has his own the parameters. Yes, am I right, Jan sir?
yes, sir. Absolutely fine. And just to add, as you rightly said, the biomedical departments, hospitals, pharma, and and the radioactive or the radio what do you call radioactive air filters, those were used into any kind of the radioactivity removal, goes through the stringent policies of decompose.
Right, right.
So there is a question from Mr. Nikunj Pamar related to the particulate HEPA filter.
No, before that we have a question from Anup.
Yeah,
Parate.
sorry.
Do we
sure,
have
yeah.
yeah.
So do we have a BI standard for indoor air purifier system for India market? So far, no. There is no BIS standard for air purifier system yet. And the government is working on air and water air purifiers these days, and trying to mandate a couple of efficiency parameters, as like the CADR into the US, even for the air purifier those being produced in India.
Right, right.
There is
Right,
another
Vishal ji.
question from Mr. Nikunj Pamar
Yeah.
related to for HEPA filters. Efficiencies derived by OEM is on paper only. Any OEM have requirement to measure efficiencies? Yeah, there are not the OEMs, but there are few labs available, in the market. Those does the measurements for their efficiency. So if you have a sample of the filter, you can take it to the lab, and there the efficiency measurement can be done.
No, even Jansab, let me share, Mr. Parmar. When you buy an HEPA filter from any OEM, you can request for the performance test, and the OEM will give you the third party check from the
Test report.
reputed laboratory, right? No,
Yes.
they give this performance test. Yes. Right.
There is another question from Mr. Joseph. Kindly send a PDF copy. Okay.
Please send a PDF copy.
All right. If there is no other question, we can probably conclude the session.
I think, sir, all question has been well taken. Or anyways, if any other questions will be there, they can send directly to Jan sir at visal.jan@mav-x.com, or you can send it to in our DCI email as well, in which you have got the link. So coming to the end, I request again Arun Dhawan sir to make vote of thanks for this session. Over to you, sir.
Thank you, Tapas. Thank you very much. First of all, I would say thank to all attendees who, I mean, came, spared their time to have this, the nice conversation from a person of IT and telecommunication, and the vast knowledge of air filtration and the purification technology. Wonderful, amazing. Your heads of Jansar, a very great knowledge to the attendees and to the society. Although आपका जो exposure है वो IT और telecommunication में है, but उसके बाद भी आपकी जो knowledge sharing है, and it is a productive session, wonderful. Or I would say we should share this PDF or the your write up to the well, as per the Ishre or the Tapas can decide with the the
Sure.
management. It's a wonderful session. Thank you very much.
Thank you everyone. Thank you,
Thank
Mr.
you very
Arun.
much.
So, with the permission of all of you, sir, should we close the session now? Finally.
I think yes. If any participants have any question or query, they can write to the email or the person concerned.
Yeah.
It can be answered. I think.
Yeah,
Should we
definitely, sir.
conclude it?
They're most welcome to send email revert back to us for this. And Vishal sir email has been already shared, and the link they have got, they can revert on that also for any kind of questions.
Right. So I think we should conclude the session.
Yeah. Thank you very much, sir. Thank you all.
Thank you, Tap. Thank you, Purnima. Thank you, attendees, participants.